You're welcome to Physics Medicine online tutorial class. I am your physics tutor, Mrs. Okuma. Now, in our previous class, we talked about refraction of light through triangular prism, and today we are continuing from where we stopped. Refraction of light through triangular prism. Remember, we've talked about the specific objectives, and today we are looking at the last objective. You want to solve simple problems on refraction of light through triangular prism. You want to look at simple problems on refraction of light through triangular prism. Now, previously we've seen first example number 1, and today we want to look at example 2. You want to look at more examples, and we are starting with example 2. Now, let's look at example 2. Let's see our example 2. The angle of incidence of a ray of light passing through an equilateral triangular prism ABC of refracting angle 60 degrees is 40 degrees. Calculate A, the angle of refraction at the first phase, B, the angle of emergence, C, if the light is incident normally on the first phase AB, describe with the head of a diagram what is the fate of this light as it passes through the prism. Now you take note, the refractive index of this glass prism is 1.5. Let's take the question again before we go to the solution. The angle of incidence of a ray of light passing through an equilateral triangular prism labeled ABC of refracting angle 60 degrees is how many? 40 degrees. So we are given the angle of incidence to be 40, and the refracting angle A, we know it to be 60. Now we are meant to calculate number A, the angle of refraction at the first phase of the prism. Number B, the angle of emergence. Then number C, if the light is incident normally on the first phase AB, describe with the head of a diagram what is the fate of this light as it passes through the prism. Now let's look at our solution. Now we have our equilateral triangle. Remember, we said that in equilateral triangle the angles are equal. That is 60, 60, 60, making it up to what? 180 degrees. So here you have 60. And remember, this is our refracting angle. Then here is also 60, and this angle is 60, making it the total sum of angle in a triangle, which is 180 degrees. Now remember question A. Question A says find the angle of refraction at the first phase. You want to find the angle of refraction R at the first phase. And remember, we are given the angle of what? Incidence. Now we say let R be the angle of refraction at the first phase AB. So look at this prism A, B, C. So we are looking at this angle of refraction here, R. So using our Snell's law, N is equals to sine I over sine R. Now from the question, we were equally given N, that is the refractive index, to be 1.5, and we were given our angle of incidence to be 40. So we substitute sine 40 over sine R. Now cross multiplication, we make sine R the subject, and that will give us sine 40 over what? 1.5. Then sine 40 gives us 0.0428 over 1.5, and that will give us 0.4285. That is our sine R. Now we are looking for R. What is R? R will give us the sine inverse, when you press shift, you press sine, that will give you the sine inverse. Then you press your 0.4285. So the sine inverse of r will be what? 25.37 degrees. So that has taken care of the question number A, which says we should find the angle of refraction at the first phase. So our angle of refraction here at the first phase is what? Our R is 25.37 degrees. Now let's look at question number B, the angle of what? Emergence. We are looking for the angle of emergence, and from the diagram you can see the angle of emergence, that is angle, this angle here, angle E. How do we find this angle E, angle of emergence? Now let the angle of emergence be E. We are going to consider this rectangle. Now look at the diagram. We are considering a rectangle now, AFPG. Look at it, it's four-sided. See it again. AFP what? G is now a rectangle. Now we want to consider this rectangle, and we look at this angle. Remember, for a rectangle the equal angle is 360 degrees. Now from this rectangle, angle AFP, look at it, angle AFP plus angle AGP will be how many? 180 degrees. Let's take it again. Angle AFP, that is this angle here, from here to here. If you add it to angle AGP, angle AGP, which is also this angle, it will be sum up towards 180 degrees. Now remember, that means this angle here plus this angle here will give me 180 degrees. Also this angle here plus this angle here will also be 180 degrees, making the sum of the angle in this rectangle to be how many? 360 degrees. Now, but since angle FAG is 60 degrees, that is angle FAG here is 60 degrees, that is our refracting angle. Angle FAG from this diagram, since it is 60 degrees, that means angle GPF will be what? Angle GPF will now be what? 180 minus 60. That means this angle here will now be 120 degrees. Now therefore R plus X plus 120 will be equals to how many? 180. Now look at this, sum of angle in a triangle. This is now a triangle. When you add R plus X plus 120, they are triangle now. They are equals to how many? 180 degrees. That means R plus X will now be how many? It will now be, you now do cross multiply, you now collect like terms. So you here you have 180 minus 120, so that R plus X will give us how many? 60 degrees. So R plus X is equals to 60 degrees. But remember, we have found our R to be 25.3. So I'm going to substitute. Since R plus X is 60, that means my X will now be what? 60 minus 25.37. So angle X here will be how many? 34.63. Now X is the angle of incidence on the glass. The angle of incidence on the glass at the face AC. So this X is the angle of incidence on the glass and the boundary on the face AC. So when we are considering the face of this triangle AC, now this angle X becomes our angle of what? Incidence. If we are considering the face of this triangle AC, this angle now becomes angle S, becomes our angle of incidence. whereby this angle E will become our angle of what? Refraction. Remember, we are looking for E. Now we continue. Now we are going to use our Snell's law, and in this case now, when you consider this now, you find out that the ray of light in this case now is now moving from glass to air. If I'm considering our angle X to become my angle of incidence and angle E to become my angle of refraction, that means the ray of light is moving from glass to where? Air. Now we are going to use Snell's law. We have that sine X over sine E will give me 1 over what? N. That is, if you recall the principle of reversibility of light. So here I have that sine X over sine E for a ray of light moving from glass to air will now be equals to 1 over N. Now I'm looking for E. So I will do cross multiplication. Here I have that. Remember my sine X, I will substitute 34.63 all over sine E, and that is what I'm looking for, is equals to 1 over N, and my N is 1.5. Here, cross multiplication, I will make sine E the subject. Sine E now becomes 1.5 times sine 34.63, and that will give me sine E to become 0.8524. Now what is my E? Because I'm looking for E, not sine E. That is sine inverse of E. As I've told you, you press your shift, the shift key in your calculator, press your sign, you find your sine inverse, and that gives me 58.47. So my angle of emergence E is 58.47. Now we look at the last question there, which is question number 2C, which says that if the light is incident normally on the first phase AB, described with the aid of a diagram, what is the fate of the light as it passes through the prism? Now look at the diagram. If the light is incident normally on the first phase, that is, the light passes undeviated. So you can see the diagram. Look at it, the same equilateral triangle ABC. Now the light passes undeviated, incident normally. Now you can see that on striking this prism here, it will be totally internally what? Reflected. Now the incident ray, if it's normal to the face AB, it therefore passes through undeviated and strike the face BC at N. So this incident ray will strike this face. Look at this face BC. It will strike it at this point N. Now here we see that the angle of incidence FNM is equals to 60 degrees. So this angle of incidence FNM, this angle of incidence here is 60 degrees. Now, but from our critical angle, we say that sine C is equals to 1 over N. Sine C is equals to 1 over N. So if sine C is equals to 1 over N, we see that the critical angle from the glass is about 42 degrees. We have seen our critical angle for glass, 42 degrees. But here we find out that this angle of incidence is greater than critical angle. That means sine 60 is greater than 42 degrees. So the angle of incidence is greater than critical angle. So the ray IN will be totally internally what? Reflected at N. So there is no emergent ray. So from the diagram you can see it that this ray, there is no emergent ray, rather the ray is totally internally what? Reflected. So here you have no emergent what? Ray. The ray is totally internally what? Reflected. Now let's see one more example under refraction of light through triangular glass block or triangular prism, and that is example 3. Example number 3, a 60-degree prism is made. A 60-degree prism is made of a material whose refractive index is 1.6. Calculate A, the angle of minimum deviation. B, the angle of refraction of the light passing through the prism at minimum deviation. Then number C, the angle of incidence of minimum deviation. The angle of incidence of minimum deviation. Let's take the question again. Let's digest the question again. A 60-degree prism is made of a material whose refractive index is 1.6. Let's take note of the known values. Here we are given the refracting angle A to be 60 degrees, then the refractive index 1.6. Now we are meant to calculate number A, the angle of minimum deviation. That is capital letter D. Number B, the angle of refraction of the light passing through the prism at minimum deviation. That is R. Then C, the angle of incidence of minimum deviation, and that is I. Now, how do we go about this? Remember, we have a formula that connects the refractive index of the prism, the angle of minimum deviation D, and the refracting angle, which we have seen earlier. And the formula says that N, that is the refractive index, is equals to sine half of bracket A plus D, bracket closes, all over sine half of A. Now this formula will take care of number A question, where we are looking for the angle of minimum deviation. That is capital letter D. So we are going to substitute from the known. We were given N to be 1.6. We substitute sine half of A plus D. A plus D, there is an omission here. Remember, we are looking for D. So this A is 60 degrees. We are given A, and A is given to be how many? 60 degrees. So we are given A, we are looking for D. So our unknown is D. So this 60 is for A. All over sine half of A, which is also 60. Now we have that 1.6 will be equals to sine half of, here is D, plus 60. All over sine half of what? 30. Now cross multiplication, we have that 1.6 times sine 30 will give me, I'm going to open up the bracket, sine D plus sine 60 is correct here. D, remember here is D, so we open the bracket, we have sine D all over sine 60, then all over 2. Then here I have the 1.6 times sine 30, which is 0.5 times this 2, which is equals to sine D plus sine 60 over 2. Now I have the 1.6 times 0.5 times 2 will give me sine D plus sine 60 over 2. Then we come down. I have that, please, this 2 is no more here. 1.6 times 0.5 times 2 will give me sine D plus sine 60, because I've already cross multiplied here. Please, this is an error. This 2 is not meant to be here. Now 1.6 is equals to sine D plus 0.887, that is sine 60. Sine 60 will give me 0.887, whereas 0.5 times 2 will give me 1. So here I'm left with 1.6. So I will collect like terms. 1.6 minus 0.8887 is equals to sine D. Now, then I have that D will be equals to sine inverse of 1.6 minus 0.87. So D is sine inverse of, when I subtract 0.87 plus from 1.6, I'm left with 0.734. So here D is equals to sine inverse of 0.734, and that will give me 47.22. So the angle of minimum deviation here is equals to how many? 47.22. Now number B question says, find or calculate the angle of refraction of the light passing through the prism at minimum deviation. Now remember what we said using geometry, that at minimum deviation 2r is equals to a. Using geometry at minimum deviation, remember we said that I will be equals to E. That means R plus R will give us 2R, and it is equals to A, the refracting angle of the prism, which we know it is 60 degrees. So here 2R will give us what? 2R will give us how many? 60. So if 2R is equals to 60, R will be 60 over 2, that is 30. So number 2 question, which says we should find the angle of refraction of the light passing through the prism at minimum deviation. Here our R is equals to 30 degrees. Now number C, calculate the angle of incidence at minimum deviation. Calculate the angle of incidence at minimum deviation. So here we are going to use our Snell's law. N is equals to sine I over sine R. We are looking for the angle of incidence at minimum deviation. So here I have that sine N is equals to sine I over what? Sine R. So sine I is equals to what? Make sine I the subject. It will give me N times sine R. Sine I is equals to N times sine what? R. Now we are going to substitute. I have that 1.6 times sine 30. That is, I have that sine I will give me what? N, which is 1.6 times sine R, and my sine R is 30 degrees. Please, this is I. So I have that 1.6 times 0.5, that is sine 30, that will give me 0.8. So my I will give me sine inverse of 0.8. I is sine inverse of 0.8. And when you find the sine inverse of 0.8, that will give you 53.133. So my angle of incidence here is how many? 53 point what? 53.133 degrees. So that has taken care of the questions. We have taken care of the question. Now let's finally look at the total internal reflection in prisms. Total internal reflection in prisms. We've talked about this when we are talking about reflection of light through prism, at plane mirror and others. So total internal reflection in prism. Now 45, 45, 90 degree right angle isosceles triangle prism are usually referred to as total reflecting what? Glass prism. So we refer this as isosceles triangle. When we arrange them in 45, 45, 90 degree, we refer them to as total reflecting glass what? Prism. Now consider such a right angle isosceles prism above. We have a ray of light incident normally on the side BC. Now look at this right angle isosceles triangle. Look at this. BCA is a right angle isosceles triangular prism. Now if we consider a ray of light incident normally on the side BC, look at this ray, incident ray. It is incident normally, that means it moves straight undeviated. Now look at the normal. Now the ray is incident normally on the side BC. It will pass straight through it and strike the hypotenuse side BA. So when this ray passes straight through this prism, it will strike the hypotenuse side BA at angle of how many? 45 degrees. At an angle of 45 degrees. So when it strike it, now look at it. Here is 45 degree. Here is equally 45 degree, making it 90 degrees. Now, as this angle is greater than the critical angle, that is the angle of incident now is 45 and is greater than critical angle, the ray will be totally reflected with an angle of reflection which is equals to 45 degree. Now the reflected ray YZ strike the glass face AC at right angle and it passes straight through such a rightward angle. It will pass straight through such a right angle isosceles prism, and the ray can therefore be used as a total reflecting word prism. So this ray can be used as a total reflecting word prism, as we can see in that diagram. So from this diagram you find out that this ray that is incident normally at BC, as I've said before, it will strike the hypotenuse side BA at angle of 45 degree. That means your angle of incidence 45 is greater than your critical angle. And when this happens, the ray will be totally internally reflected. The ray becomes totally internally reflected. Now, you find out that the reflected ray YZ, you can see the reflected ray YZ, reflected ray YZ will strike the glass face AC. So this reflected ray strike this glass face AC at right angle. It will strike the glass face AC at right angle and it will pass straight through such right angle isosceles prism. So here we have total internal reflection. The ray was totally internally reflected. Now the same thing, a right angle isosceles prism, we can arrange it in such a manner such that the light incident on it is deviated through 90 or through 180. So in the first one, it is deviated through 90. Now we are going to look at this. You find that we can equally arrange this isosceles triangle such that the incident lights on it will deviate through 180 degrees. Now look at this. You can see the incident ray on striking the prism at this side. It will enter the prism through BC and it will strike this prism at side BA. Look at it. On striking the prism here, it is reflected. Now here you have 90 degrees. So here is 45, 45. Here is also 45, 45. So 90, 90 gives us 180. And here the ray will be totally internally reflected. So we can see this in a isosceles triangle of 90 degrees and also in a triangle of 180 degrees. Now let's look at our evaluation question. Number 1, we are evaluating all we have done in refraction of light through triangular prism. Number 1, a ray of light is incident at an angle of 30 degrees on a glass prism of refractive index 1.5 Calculate the angle through which the ray is minimally deviated in the prism. Now the medium surrounding the prism is what? Air. The medium surrounding the prism is what? Air. Now number 2, remember in number 1, you are given the angle of incidence to be 30 and the refractive index to be 1.5. You are meant to calculate the angle of minimum deviation. Number 2, explain the necessary steps needed to find the refractive index of a triangular prism. And finally, with the aid of a diagram, describe the total internal reflection through isosceles prism of 180 degrees. Now we have come to the end of our today's lesson. Thank you for your patient listening. I remain your physics tutor, Mrs. Okuma. See you in our next class.